Now that we've talked about the basics of exponential functions, we're going to talk about how to use the terminology to kind of solve some real-world problems with it. Okay, so before we actually get to the problems, we're going to talk about what some of these terms mean. So if, for instance, in a problem they say that something is doubling, well, if something's doubling, that technically means that you're multiplying by 2. And so that means that it's growing, because if you're multiplying something by 2, it's growing. So your growth factor would be affected here. And your growth factor, which is, if you remember, that's your b, would actually be 2, because that's what you're multiplying by. So the growth factor, your b, would be 2, because you're multiplying by 2. Whereas if they said something is tripling, well, tripling technically means that you're multiplying by 3, so that would also be a growth. So that means that your growth factor, that b, will be affected. And this time, the b would be 3, because you're multiplying by 3. Tripling means multiplying by 3. And then what if it said, well, something is half the size? Well, when you take something and you're cutting it in half, or it's half the size of what it was, that actually means it's becoming less. So that means it's decaying or going away. So that means that it's you're going to talk about it in terms of a decay factor. And it's still the b, but this time it's decaying, because think about what you're multiplying by. If it's half the size, that actually means that you're multiplying by 1/2. So your b would be 1/2, or it could also be written as a decimal, which would be 0.5. And another way to think about that is it's 50% of what it was, which will come into play in a little bit. All right, so let's talk about how to kind of use some of this terminology to solve problems. All right, so it says in this problem, suppose an animal's population doubles every month. So think about what we talked up there. Double means that you're multiplying by 2. So that means that your b in these equations will be 2. Your growth factor will be 2. It says, how many animals would there be after 3 months if it started with 20? So if they asked you to write the equation, you could very easily write it down. So I'm going to copy this equation that we talked about earlier. Okay, so we've got f of x, or you could write it as y, equals a times b to the x. So to write my equation, well, a, remember, in the word problem world, is what you start with. So it says it started with 20 animals. So that's going to be your a. So that's what goes in for that. And then your b, and you could write it as, you can write the multiplication sign here, or you're going to notice a lot of people put parentheses, so we're going to get in the habit of doing that. It's whatever you're multiplying by each time. And so here, notice it says it's doubling. So that means that we're multiplying by 2. So that's what goes there. And then you write your x. Okay, so that's your equation. So now it's asking how many animals would there be after 3 months. Well, this comes from kind of knowing about your equation and what your x's and your y's represent. So think about it. What are you observing here? You're looking at months, and then you're looking at how many animals there would be. So like you could look at it this way. So that would be like months. After 0 months, how many animals? I have to write that down below. Didn't leave myself a room. So after 0 months, how many animals would there be? Well, at the beginning, there were 20. So after no time has passed, there's 20 animals. After 1 month, it says it's doubling. So then how many animals would there be after 1 month? Well, that doubled times 2 would be 40. And then you could keep going, which we can do that. And you could find the answer pretty easily by doing that. Or you could use your equation. So notice your x values were your months. Your y value, which is your f of x, is your animals. And so with this problem, we're actually looking at when the x is 3. And so another way that you can find the answer to this is you could plug in a 3 for x, okay? Or if it's something that you could easily keep the table going, you could do that. But either way, you will notice if you start out with 20, it's doubling. Well, your x is months, so after 3 months, you could plug in a 3 right there. If you type that in, you end up getting 160. And so after 3 months, there will be 160 animals. So you could set up your equation, or if we kept this table going after 2 months, well, double it again, you get 80. And then after 3 months, double it again, you get 160. So either way, you get the same answer, okay? So that's how you set up an equation. That's how you do it with the table, all right? So this next one, we're going to just set up our equation. So it says, suppose a bacteria halves itself every day. So it's this one, I want you to realize, because I think that one's kind of written a little weird, or maybe not written the way I want it to be. What this is meaning is it's half of what it was, so it's decaying, okay? So I want you to make sure that you realize this, I meant for it to be half of what it was, okay? So if that's the case, then that means there's only going to be half of it left each day. So that means it's decaying, so it's a decay. And your B, well, if it's half of what it was, that means you're multiplying by 1/2, okay? It says, how much bacteria would there be after 4 days if there were 100 to start with? So if we write our equation, so we're going to just set up the equation this time. I'm going to copy that down. What did we start with? That's what goes there. So there were 100 to begin with, so that's what goes for A. And then my B is whatever we're multiplying by. So if it's half of what it was each day, that means we're multiplying by 1/2. Okay? And then you copy down that X. And so now you have to look at what your X is. So what are my X values in this problem? Well, we're looking at how much bacteria there is after so many days. So your X is the days, and then the equation, or the f of X, the Y value, is the number of bacteria. So make sure you label that so that you know. And so if we're finding it after 4 days, we just have to plug in a 4 right there. So it'd be 100 times 1/2 to the 4th power. And then you can type that in, and you will notice that if the bacteria continues to be half of what it was each day, after 4 days, there will only be 6.25 bacteria left. And so notice how fast that went down, because it started out with 100, and then after just 4 days, there's only 6.25 left, okay? And so that's kind of, if you think about the graphs of decays, it starts out high, and then it quickly goes away. And so that's why, is it's quickly decaying, okay?